Okay, so it says a jack screw. This is example 10. It says a jack screw with a handle 30 centimeters long is used to lift a car on the jack. Okay, so let's write down everything. You know what a jack screw is? A jack screw is literally a jack. Any kind of screw is really an inclined plane. So a jack screw is just a circular, well-built, nicely engineered inclined plane. Yes? And when you change tires, oftentimes you have a lot of the cars, especially European cars and Japanese cars, they have jack screws. Whereas in America, you have something a little bit different. Okay? I like the American jacks a little bit better, where you're pumping it up and going up a notch. Do you know what I'm talking about? You've seen them? Yeah, they're a little easier to use. The jack screw takes forever, but they're certainly doable. Okay, a jack screw with a handle of 30 centimeters long is used to lift a car sitting on the jack. The car rises 2 centimeters for every full turn of the handle. What is the ideal mechanical advantage of the jack? Okay, so we have FO, FI, DI, DO, DI over DO. Let's see what they have. It says a jack screw with a handle of 30 centimeters long is used to lift a car sitting on a jack. The car rises 2 centimeters for every turn of the handle. So every turn of the handle. So when you think of turn, what are you thinking of? You're thinking of the circumference of a circle, correct? Turn it once, turn it twice, turn it once, turn it twice, right? Yes? So you know that the jack screw is going to be, the ideal mechanical advantage is going to be equal to 2 pi r over delta h. Correct? Yes? Now, let me go back and read this. Okay? Here's the screw, right? That's the screw. Correct? Yes? The handle is 30 centimeters. Correct? And it's going to go like this. Correct? It's going to go like that. Yes? Okay. So that's the radius. That's r. Correct? So when it says 2 pi r, I'm going to say IMA equals 2 pi and then 0.3 meters. You've got to change. We know that the radius is 30 centimeters or 0.3 meters. Correct? So you got to change those units. Correct? And then for every one circumference, every one turn, right? For every one turn, the height change is going to be 2 centimeters. Or this has got to be 0.02 meters. let me ask you a question. Do you really have to change it to meters? No, because the meters will cancel, the centimeters will cancel, correct? The ratio is the same. 0.3 over 0.02 is the same as 30 over 2, right? So what is 2 times pi times 0.3 divided by 0.02? Now, Mr. I'm fascinated by my calculator. Now you can use it. You see the difference? Yeah. Yeah. You having a problem doing it? A little overwhelming, isn't it? It's not? What do we got, guys? What is it? What do you get? Anybody? 94. Yeah. Well, I mean, yeah. But do you get it on your calculator? Okay. Yes? Okay, let's do this. Let's take a quick road trip. Let me just turn this off.